So I'm Julien Enoch. I present the slides in the behalf of Angelo Corsaro that was supposed to present today, but unfortunately which were not able to come this week. He apologizes for this. So I will start with a brief overview of our company, ADLINK. So ADLINK is a hardware company building hardware, mainly in embedded. It has been founded in the 90s. It's a Taiwanese company, which is now public, so it's in the Taiwan Stock Exchange. And we have 1,800 of employees. And last year we reached the $300 million of revenue. So our offices are spread all around the world, mainly in Asia, of course, but also in Europe, and with also big offices in the US. The R&D office are mainly located in Asia and in Europe, as we will see for the software. So we benefit continuous growth since the last 12 years with a 15% of compound annual growth rate. And a lot of, well, a big part of this growth is reinvested in the R&D constituently, and moreover in the last few years with the opportunities we see in the IoT market, industrial IoT market, and in the edge computing and fog computing. So what do we do at ADLINK? So the tagline of ADLINK is leading the edge computing. That's a goal for us, is really to provide to our customer robust and reliable hardware platforms, as we do since now more than 20 years, but moreover those years, adding data connectivity and complete industrial IoT solutions. So really, we would like to be a leading enabler for the edge computing and reducing the complexity to build industrial IoT systems. And also to connect the unconnected, meaning, in a lot of factories, you have a lot of hardware which are not necessarily connected or connected locally. We want to allow our customer to connect those hardware and to be able for them to exploit their data wherever they want, in the cloud or in other places. So our markets and key customers. So when we spoke about industrial IoT, that's cover a wide range of activities and markets. Of course, industrial automations and test and measurement for the factories themselves, but also medical. We provide hardware for the medicals, certified tablets, which are constrained for the cleansing environment when you have a lot of cleansing products, and also in transportation, where you have some constraints of vibration, of heat, and so on. All our hardware in general is certified to support -40 up to +80 degrees Celsius. So this is already constrained hardware that supports also vibration, dust, and a lot of hard environments. So we provide also telecom hardware like switches, routers, and for the military, and also for infotainment. So certified machines for the casino and so on. All kind of hardware that we provide for healthcare infotainment are certified, rugged for industrial life cycle. They are standard based, so we provide a lot of tablets, of small devices, cameras also. We provide cameras allowing to supervise, for instance, a factory, a line of production with some intelligence embedded in the camera itself. Of course, for the edge, we provide IoT gateways for brownfield or greenfield connections. And in the networking sector, we have a wide range of devices that we can provide. In software, ADLINK recently acquired a company named PrismTech, where I used to work. And now ADLINK is able to provide software solution for real-time sharing data between systems based at this stage for on OMG DDS. That PrismTech was a founder of the specification of DDS, so they are not part of the ADLINK company. And we also provide help for our customer to design some hardware that they want. If they have some specific needs in their hardware, we have teams able to help them to design the platforms that they need for their specific requirements. Okay, we are also active in lots of partnership and alliance. I will not list all. I just list this one, Intel. We are premier member of Intel, one of the 5th premier member of Intel, meaning that we have access to the latest Intel specification and latest chipset, and we embed the Intel chipset in our platforms. We also are a member of the Open Fog Consortium. As you will see, it's very important for us to push this fog concept. And of course, recently we joined the Eclipse Foundation as a member, because we would like to push some software as open source into the Eclipse group for the benefit of our customer and the benefit of everyone. So, in the ADLINK company, I'm working in the Advanced Technology Office, so that's a laboratory in ADLINK, which mission is really to scout to the new technologies and to identify and de-risk technologies that can improve the ADLINK competitiveness. And we really would like to innovate. We explore new solutions, new technologies, and of course we will evangelize what is the ADLINK vision in those technologies, and help our BUs and our customer to win market shares. The area of focus we have in our research laboratory in the Advanced Technology Lab are part of that's the slide coming from Gartner last year, the top 3 trends in the research. So in AI, of course, for instance, we are working on cameras which embed some advanced GPUs that will run the AI. Thus, we will have automatic detection, for instance, of patterns in the camera, and we won't need an external device for this. That's also related to machine learning. And in the digital platform, we are of course working on edge computing that we will explain now in 5G and IoT platform, as well as blockchain and digital twins, and also activities in serverless platform as a service. So, making fog computing, that's our goal right now. And what is the context of this? What we see in our experience is that generic IoT and IoT system have 3 different parts. The first part is off the premises, so outside the world of a company. It's a data center. So it could be a private data center or a public cloud or a private cloud. Anyway, that's big data machine which are outside a factory or outside the premise of the customer. Then on the premise infrastructure, you have of course the things which may have or may not have computational, which are usually communicating, which may have storage capacity. Things are small devices or big devices such as robots in a factory, or autonomous vehicles, or medical hardware in a hospital, for instance. So they may have various category of devices, of things that are present in IoT. And between the data center and the thing, we have the edge. So the edge is usually on-premise, so in the infrastructure of our customer, and it's usually gateway servers or also traditional PC servers with computational and possibility and storage, more storage capacity. So they are usually more powerful from the things. Not often. It may be just, for instance, a Raspberry Pi that you deploy at the edge for some computational purpose. So we can see anyway that we have a clear boundary in our experience, which is between the data center and the edge. That may not be the case in every domain, as we will see in the next slides. So For those historically, those IoT systems have been addressed by a cloud perspective. So they have been, the cloud has been very successful in the past years. So the people are used to deploy application and storage capacities and their infrastructure in the cloud because it was mature and it was operationally convenient. Yet we think that the cloud-centric architecture don't feel well for a large class of application for our customer mainly in Industrial IoT. The way it used to work, the customer deployed their application and in the data center. They are managed and monitored here, and the things are here just for data acquisition from the field and digitalize those data and send directly to the data center where all the computation is made, all the control is made. And in some cases, in a lot of cases actually, you have command coming back from the data center to the thing to actuate the state of the things. No, this faces to some constraints in the IoT system, in the Industrial IoT system. Due to latency, throughput, connectivity cost, and security, this won't fit with a lot of application. For latency, for instance, when you have a cloud which is far away, you may have dozens of milliseconds of latency, and that may not fit all your application. For instance, for a robotic application, you cannot afford to have milliseconds of latency. Throughput, it's the same. You may have a full factory with a lot of devices producing gigabytes of data per second, per minute. You cannot afford to push everything to the cloud because of your connection throughput. Connectivity, we have experience, for instance, with some customer, John Deere, which have tractors in the fields in the US. In the US, in the middle of the land, you don't have always the full connectivity to transmit all your data at any time to your cloud. Same for the cost. For instance, we have some customer in oil rigs in the middle of Africa or wherever. They don't have a 2G connectivity, they only have a satellite communication. And 1 megabyte of satellite communication can be up to $8. So there is a cost to what you send to your cloud in some cases. And of course, security. That's a big trend for medical. You don't want to have all your patient data to be deployed in the cloud or in a secure way at least, but usually it's more secure to keep everything safe in your infrastructure, possibly just to send sanitized data outside in your cloud for some analysis, but with anonymous data. So the reality is really that for IoT system, we need to deploy applications and to provision and manage those applications along the full path of the data, up from the data center to the edge and down to the thing, because sometimes you want to deploy application directly on your thing. If you have a vehicle or a robot, you want to deploy your application, to upgrade your application and manage it directly in the thing. So, fog computing, that's a definition that was agreed in the Open Fog consortium that we were a member. So we pushed for this definition. So we consider fog computing to be horizontal system-level architecture that distributes computing, storage, control, and networking function closer to your user along a cloud-to-thing continuum. So that's very important, this cloud-to-thing continuum, because really that's not only pushing the application to the edge, but also down to the thing. That's what we think. MEC. MEC stands for multi-access edge computing. That's a standard coming from telecommunication. It used to be named actually mobile edge computing. It's slightly different from what I just described in the industry, in the sense that the boundary of the premise is not at the same place. In the industry, the boundary was here, just before the fog, the edge, and the things. Now in telco for 5G, that's mainly come from the 5G initiative, you will have those multi-access edge computing hardware, which will be deployed in the telco infrastructure, but close to the antenna, so close to the user using the 5G infrastructure. And users or telco providers would like also to deploy some applications, specific applications, to this multi-access infrastructure, the same way they would like to deploy in the edge infrastructure. So in this case, it's a little bit like the opposite of the fog. You have the edge infrastructure, which is off the premise of the customer, but on the premise of the telco provider. Anyway, what we want to address is really deploying, managing all the application along either the fog, either the MIC. That's why we propose our new project, Fog05 or Fog OS. You can name it as you want. That's you can play on the name with this. 05 because indeed it addresses the 5G issues. OS because it's not really like an OS, but it's really a system that will allow you to manage all your applications along this cloud-centric continuum. So the goal of Fog OS is really to unify the compute, the storage, and the communications along the cloud-centric continuum. So it will allow you to unify the administration, the management, and the monitoring of your application end-to-end from the cloud to the things. It's designed either for the fog, either for the MEC. In Fog05, we define entities. So entities is either an atomic entity, such as a virtual machine, a container, a Docker, or something as simple as a binary executable. So Fog05 will be able to manage, to provision, manage, and deploy all these entities. And entities can be composed in atomic entity can be composed in a direct acyclic graph of entities that will be also considered as an entity. So we have a composition of entities that you will be able to define and to deploy in your infrastructure. Each hardware you have in your infrastructure have some constraints. You may define some different constraints such as CPU, I/O. Does it have an accelerator, FPGA, a GPU? What kind of I/O? It could be Ethernet, it could be a CAN bus, it could be whatever I/O you want, and you need to deploy the correct application on the correct hardware. So you will be able to define affinities on each of your entity. Does it need a CAN bus? Does it need a GPU? What kind of how many memory does it need? And then Fog05 will be able to direct the deployment to the correct hardware. You may also describe some geographical affinities, forcing an application to go to this hardware specifically. Fog05 is highly pluggable, so there are different pluggables to deal with different kind of entities. All those kind of entities, you will be able to write your own plugin if you want to manage your own binaries or your own entities. Also, for the management of the infrastructure, it's pluggable. You will have plugins to discover the topology of your infrastructure and the constraint of your infrastructure. On the architecture stage, Fog05 is mainly an agent. So you will have agent deployed in all places of your infrastructure, and this agent is based at the lower level of a named data network infrastructure. Named data network because it's based on URI. So it's mainly it's comparable to REST, organized by URI, but it's based on a new protocol named Zeno that we developed, and this protocol has a particularity to not be reliable on IP. It can be deployed on Bluetooth, on Z-Wave, on UDP, on TCP. You will have different way to deploy it. It doesn't require necessarily as a transport layer. We also support at this stage DDS, which is a data distribution system. There will be a presentation tomorrow on Cyclone DDS, which we use for OS. On the top of this, we have IAX, which is a distributed key value store that we use to distribute all the information of our system on all the information of applications that need to be deployed, but also possibly to store the image of what you want to deploy, such as unique kernel. And the agent is the core logic of FogOS that taking care to manage monitoring and orchestrate the entities. And everything is highly pluggables for the entities management, but also for the OS, for the networks and so on. So by the way, we are able to manage a network. It means that as we don't rely on the transport layer, we are able to deploy in the agent. Once the agents are deployed, we are able to configure the network, to configure an overlay network, for instance, and configure a private VPN for the communication between all the infrastructure. And we are also testing now the possibility of tunneling of all the overlay traffic across some brokers in the DDS or in Zeno in order to be able to have the same protocol end-to-end from the things to the cloud. So the deployment, Fogwell will be deployed on an OS, which run either on a bare metal or on a VM, and it will be able itself to deploy VM. So usually we'll want to be able to deploy the FogOS agent on a place when you can manage the hypervisor in order to deploy other VMs or deploy other unique kernels. What we foresee and what we are working on is that FogOS will be deployed natively on AT, a trusted execution environment, such as, for instance, MirageOS. So we are working on this. We are working on implementing FogOS now in OCaml, which is a native language of MirageOS, to allow deployment in a trusted environment. And why this? It's because really those trusted environments minimize the surface of attack of your hardware. When you have only a trusted environment, that's the only environment in your hardware that is managing the communication. So once we have only one way to communicate with the things, and that this trusted execution environment is already secured, you're in business, you're more secure than with regular Linux or regular Windows, with all the bugs on the surface of attacks that we know in those OS. So once the agent is deployed in the T, it will be able to start other VMs, possibly to deploy some agents in the other VMs, and then to deploy some microservice, some containers, or some native applications. FogOS is now an Eclipse project. We just started to commit in this Eclipse project. It's available on GitHub. It's available on fogo5.io. Unfortunately, not yet available because the domain name is actually in transfer to the Eclipse Foundation. So it will be hopefully available very soon. And otherwise, you can look on GitHub. The Fogo5 project is available. You can have a look. You can have a test, and give feedback for your experience. So, in conclusion, we really think that the future of IoT is on the edge. That's where the user will want to have their logic, their applications, because everything really can't go to the cloud. You will have more and more application close to the things that you want to control or you want to acquire data from. And ADLINK is really committed to help the customer to build the fog computing on both sides, the hardware part and the software part. We really would like to provide the customer a full solution with hardware and software, but also to give the software as open source to the community for those who want to experiment by themselves or to deploy by themselves or on their hardware. So that's the conclusion. Do you have any questions? Thank you. Thank you for your attention.